Alright, so here we're going to be talking about a counterexample. Counterexample is a very powerful tool in mathematics, and we're going to see why right now. So counterexamples are really good because they actually save us a lot of work if you're able to see one or find one. So here we have a conjecture. Right? In a counterexample, we can use those to prove conjectures false. Because remember, a conjecture again is based on a pattern, and then you're going to come up with some type of statement, which in this case a person found that for any real number, right, we'll call it x, for any real number represented by this, if you take that number and you square it, well, that's going to be greater than or equal to the original number that you started with, right, the original real number. So that's somebody's conjecture. And there, again, a conjecture is based on some type of a pattern that you've observed. So let's look at some of the things that this person saw. So they saw that for any real number, and you might be wondering, what is a real number? Right? Math, there's no fake numbers. We do have real numbers, and real numbers are basically any number you could think of. It could be, a fraction. It can be the square root of a number, so some irrational number, right? So like the square root of 5. It could be, let's see, some negative, 3.7, like repeated, right? So any number you can think of, fractions, it could be 1, 0, anything. Any number you can think of. Because there's two types of, the other set of numbers that we're not talking about here is imaginary numbers. But all we have to pay attention to here is a real number, right? So think any number you've experienced in mathematics, square roots, negative numbers, right? Negative numbers where the repeats, the decimal repeats, fractions, so anything you could think of. And they're saying so for any of these numbers, right? And any of these could be represented by x. So when you read something like this, don't look at x and just say it's just for any real number x. No, it's for any real number. And when they put a letter afterwards, they're saying that let's represent this with the letter x. So any real number, which could be any of this type of form, right, represented by x, if you take that number that you started with and you square it, then it's going to be greater than or equal to x. So let's look at a couple of these to see, based on the pattern they observed, they're saying, okay, so if I take 1, so like let x equal 1, that's how you should be thinking about it when they say real number x. So if I consider when x is 1, and they're saying, okay, well, take that number and you square it. So if I take the number x, represented by x, which is 1, and I square it, that should be greater than or equal to the original number. Well, I started with x equal to 1, so, and if I simplify this, let's see, what's 1 squared? That's the same thing as 1 times 1, and then I get greater than or equal to 1. And 1 times 1, I can see I get 1 is greater than or equal to 1. Is that true or false? Well, that's true. So it does happen to work out, right? In this real number, I noticed that if I take the real number that I started with, if I square it, well, that's going to end up being bigger or equal to the original, right? So I started with 1. Let me start with let's say x equal to 2. Or actually, let's do when x is the fraction 1/3. We'll try that one. So when x is 1/3, right? So if I have x is 1/3, now I'm going to take that number and square it. So I'll take 1/3 and take that amount and square it. That should be greater than or equal to 1. And remember, when you square a number, you're saying 1/3 times 1/3 is greater than or equal to 1. And then I can see here 1/3 times 1/3, I get 1/9 is greater than or equal to 1. But wait a minute, 1/9, that's less than a whole amount, and we're saying that less than a whole amount, right, which is less than 1, we're saying that number is bigger than or equal to 1. This is not true. And when you're able to find some type of a situation that contradicts what we're saying in our conjecture, that is called a counterexample. So we found a counterexample. when x equals 1/3, this conjecture is false, and this is proving this incorrect, right? So this is again a counterexample. We found a number when x is 1/3 such that this conjecture, this statement we said is incorrect, right? So it's false. So now we know that this is never true, right? Because we found one case where it isn't true. So once you find one case that it doesn't work, then this conjecture here is no longer valid.